this should be actually the value of 10 instead of 2. This should be the value of 10 because this would be interpreted by the JavaScript parseInt function up here within the X as a decimal value, but it's being passed into its base parameter to be interpreted as a base 2, which is binary, and this is not in binary, this is decimal. So parseInt is not designed to implicitly detect whether or not it's not backwards compatible in that way to do the reverse. Whereas if this was given a 10, the value 1, 0, or 1 followed by 0, it would pass into base the value 10 and the value 3, 2, 1 into X, and then it would say it is a number. It would detect as being valid. Is not a number parsed, it would return 0, but if it was, see, the reason why it's returning 0 here, it does return 0 out here as the expected output, because the programmer knew that they were passing base 2 instead of base 10. See, this is base 10, not base 2. And the programmer knew that, and that's why they knew that it would return, it wouldn't compute correctly. parseInt would not compute 3, 2, 1 as binary base 2. The programmer knew it wouldn't, these two would not work together. Whereas if this was given the value 10, they would know that the expected output would be instead, since they're assigning it a constant value here of 3, 2, 1, they would know that their code would multiply that, would detect that it would detect first that 3, 2, 1 is a number, so then it would then multiply 3, 2, 1 by 100, and that would be we just do this, 3, 2, 1 times 100 equals 32,100. If the second parameter here in the rough scale function was, this is the second parameter, if it was given the value of 10, this 3, 2, 1 that's passed into rough scale X, followed by if the value 10 for base 10 would be then processed with the parseInt, the JavaScript parseInt function, with its associativity aligned with the first parameter being the values 321 as a string at first between these single quote parentheses, the opening and closing ones, indicating that this is actually a string of literal text that would be stored within X here, and it would be converted and interpreted with as a base 10 numerical value it would strip away these apostrophe opening and closing single quotes, or apostrophes opening and closing, and take the whole decimal value of that is in base 10 and truncate that, the opening and closing single quotes or parentheses, and then it would person would interpret it accurately as a number that would be stored into the variable parsed, and then parsed would see that it is a number and not it would skip this line of code. It would skip as soon as it says it is a number, and it's instead to be interpreted as 321 instead of detecting it as is not a number. Okay, so, and then basically we take 321 times 100, and the expected output would not be 0. It would be this. Okay, if this second parameter was changed from base 2 to base 10, whereas this is base 16, which is appropriate to read anything that has a string literal that is prepended with a 0x followed by an alphanumerical value of anything between the numerical values of 0 through 9 and 8 letters A through F. That's what base 16 hexadecimal does. That's why this expected output is accurate, because it reads it right. It tells parse int. I don't know if I'll be able to do it here. I'll just do this. Tells parse int to do like there. It does something like this. Parse
a box of spaghetti that just opened. Or was open. And nobody ever
of
closes
0x f.
I'm so tired of it. Boxes upon boxes open.
16.
Why?
Base
Why
16.
do you open the spaghetti area?
I'm busy. I don't worry. I can't talk right now. Okay, I can't. Okay, so okay, Mom.
No,
wait. Okay, great. Yeah. I know. I don't know. Okay, I'm busy. Okay, so here. 0x f would be converted to 15. So it is a number, and it doesn't detect is not a number, because obviously 15 is a number. And then it would take 15 times 100 based off the way that program was written. And it would, the expected output is 1500 as displayed here. Because this is interpreted by parse int to be in base 16, and then it is stored in here as the value 15, the converted value 15, and then because 15 is the integer conversion of anything to the of the hexadecimal value 0xf being appropriately read as base 16, and then it is converted into its integer format using those two parameters into the value of 15, and then that value of 15 is multiplied with the asterisk or multiplication operator by 100, and then you get 1500. See, that's how they know. Whereas this is not being interpreted accurately
Leave it for a while.
as a decimal value because it's being given by the programmer of base 2 instead of base 10. There you go.